Hello, 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 hello. Checking my mic. Hello. Okay. So in previous stream, as you know, we have done this rendering of the triangle. Now we will understand the code, how it's done, like how rendering is done, how a single pixel is rendered through OpenGL. So if you remember, we have learned about VA and VBO. Let me share the Mila notes again. So as you remember, this is VAO and it has many pointers which points to the VBO. VBO contains our buffer data where VBO contains our vertices. Vertices can be anything like our texture or the position like this, as you can see. Then we have to now run what is shader program, how many times it is run throughout the render, and like what we have done, how we have rendered the triangle. And also we will learn like how we will render the triangle. Like past time we used ChatGPT to write the code, but this time we will write by our own. So let's just understand first like what is the shader and how it is done. First, what is shader? So it's a small program running the GPU, not in the CPU. Okay. So you must write shader. GPU will not render anything without them. So we are going to focus on vertex shader and fragment shader for now. Vertex shader, where does the triangle go? Definition: the vertex shader runs once per vertex and decide where that vertex should appear on the screen. Like we have, suppose in triangle we have three vertices, right? So it will run for three times for each vertex at a time. Then, then here's the simple code that we used previous time. So what this code says, let's understand that, okay? So first it is saying that go to location 0 and take input a position like a pose, right? It is saying that get position from location 0. From location 1, get the color. Let's understand here. This is explanation line by line. So first we are setting up our version, which is 3.3 330 code, and we are using the core profile as we already said. Then using the in keyword, we are saying that take this input to this shader from the VBO. Like we have the buffer VBO, right? Where all the data is stored about the vertex. And with the help of VAO, we are saying that it is the pointer to the VBO. So VAO helps to take input to this shader. One in variable is equal to data from one vertex. Okay. So for each vertex, a pose its position. So the variable a pose, here we defined a pose and a color. It's defining the position and the color, right? The position and color both are vector 3, so we are using the vec 3. Now we are setting that it's the layout location. For the first we are setting it to 0 and for the second we are setting it to 1. So what I am saying is that we have VBO, right? So in VBO, this first location is for our position of the vertex, right? Then this second position is for color. Now as we know that VAO contains stride. Stride is like skipping a place so that where we next time go contains the same data about the position or the vertex of the vertex or the color or the texture, whatever we have saved. So the stride is of, let's say, 1 unit. So we go from here to here, containing our this in this we are containing our position, and in this we are containing our color. So this is for vertex 1, v1. This is for our v2, and the third one is v3. So it has some what we say coordinates x, y, z. Then it has color. Both are vec3, means it will be x, y, z, and x1, y1, z1. So we have both color and the coordinates. Now this is v1. We need two more vertices to draw the triangle first. So this is v2, this is v3. So this is how our data should look like when we are drawing our triangle. And this location is represented as here, and this one as here. Now it totally depends how we are storing our data in the VBO. Like if we have three things, let's say we have also have texture, then these three blocks are for color, position, color, and texture. So this third will contain texture. So we will say like layout, location equal to 2. So it is like that. Okay. You may have understood till now. Let me erase this. Okay. So now connect shader vertex to the vertex that we must match. Yeah. So how did we get it here? Like how this code knows that on location 0 you have to use this, you have to use this. In the main code, like let me show you. It is. I think I used it down there. Yeah. So as you can see, GL vertex attribute pointer, this is saying that it's layout location 0. So we have stride vec3, the input that we are going to take. Then it is of type float, right? And what we are saying is after 3 units, if we go 3 units, then you will get the same data type. Like if it is position, then we will get the position. Then it is saying the offset. The initial offset is 0 because we are going to, like in our data share, our first point is location, so we don't have offset till now. But if we are using this for color, let's say I copy paste this. If I copy paste this and let's say it's 1, then what it will do is it will go one step ahead, and from there it will start. So our stride is again 3, but this time it will go to color first, then it will move on and move on. Okay, I think this is the enough information for the vertex shader. And let's discuss about what is vec3 and out keyword and in keyword. Let's understand that too. First, a vector with 3 floats. It is a vec3. It's simple as like you have learned in the mathematics. Like it is simple vector, nothing else. It can be position or it can be color. So as you can see last time, we used its position, a color, its color. But both were vector 3, right? Now it is saying that out vec3 color. Out means output of vertex shader. So where does this output go, right? We have to understand it. So we need the pipeline again. So here's the pipeline. Let me go upside. I can properly make you understand. So we have vertex shader. Before vertex shader, there is a buffer from where the data came. The buffer is the VBO, right? And it has POS pointer. which stores where the data is, what stride it has, and like what type of data it has. So V contains that, right? Then we have vertex shader. Vertex shader is for rendering the position of vertices, right? It runs for, let's say, if we have a triangle, it will run for 3 times. So like it will be running for 3 times. So it's not that heavy, but now it will go to like this from here to tessellation, geometry shader, what is like many things, right? But we know that we have to go from here to rasterization, right? So what does rasterization does? Like it divides the vertices. I think let me see it again. So we are going to render triangles for today. Now, as you can see, what does rasterization does is there are three vertices, right? Rasterization, a fragment is aligned to a pixel grid with a depth. I don't think it's good. Let me see the what do we see pipeline. Yeah. OpenGL. So yeah, it is what it is. We have three primitive vertices, and like after rasterization, it will fill up the inside of it. It is only that, right? So if we do this, after this, we have to give it color, right? For color, we have to go pixel by pixel, right? We have to give color to each pixel. So it is a heavy program that we are going to run that, that is called fragment shader, right? Fragment shader. So fragment shader can run thousands and millions of time, like it's so heavy program. So if you are making your own shader, be careful in this, right? So let's again go to our program where we left. Yeah, here. So what this one is saying that GL underscore position is equal to vec4. It is a vector for like just leave it for now. I will explain it in the later part. For this, just understand that it is a vector for a pose comma 1.0, right? We are adding like what is this syntax? If you have to understand that, you can search it on the website called Learn OpenGL, but for simplicity, I would explain it like this: like we have a vec3, right? Then we also have one more coordinate, and it is vec4. It's simple, like it's augmentation, right? So it is like this only. We can also write it like vec4, then manually writing 1, 2, 3, 4 data points. Like it's up to you how you are programming your shader, right? Now it's a built-in variable that you have to understand. It's mandatory, tells GPU where the vertex is in. So how the data is passing through the buffer to this vertex shader, let's understand again. This is our vertex shader, this is our buffer from vertex shader, then vertex shader assigns location. So this is the location. It runs for each vertices. So this is for first vertex. It run and it assign the pixel to our screen. Right. This is what is happening right now. Now, why vec4 and 1.0? So here it is. OpenGL uses homogeneous coordinate x, y, z, and w. W is the normal position. Like we will understand it after like understanding three, four more things. What is this W thing? Okay. Now let's understand about fragment shader now. Now, what is fragment shader? It assigns color to each pixel, right? For each pixel, the fragment shader runs once per pixel and decides the final color of that pixel. Right? So if your triangle has 40,000 pixels, it will run for 40,000. So it's so heavy that if you have if you are making a game, right, and using this renderer or like this render pipeline, it may it may uh, it may be like so heavy that it can fault your game, like it will not run. It's so heavy, right? And here's the code sample, and we will explain that too. The same thing, we define the version, then we are taking input v color. Now from where this v color input is getting in, right, you have to understand that again from vertex shader we are going to rasterization, and from rasterization to fragment shader. But for this, leave rasterization because we can't control the rasterization by ourselves. So we are going from vertex shader to a fragment shader, right? Now we have we have defined a variable here for the color. We have defined the variable for color, and we are assigning it in the fragment shader. We are assigning it in the fragment shader. Now from the fragment shader we will get the color for the first pixel, right? We are doing it for all the pixel, like if it is 40,000, then we will be doing it for the 40,000, right? Now we are also saying that take this frag color. Now as we know that main function is there, it will be running for the first time. It will assign the color to the frag color, and we will take it as output. So we will take it as output, and where does this color will go? It will go to the program, and it will render it. So if we have triangle, then it will render like points, 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 and then like pixels. So it runs like that. Again, same thing in keyword. You have understood till now what is in keyword here. What does interpolation means? Uh, so we have vector 3, right? And for vector 3 we use RGB values, and there is one more term, this 1.0, it is for alpha value, RGBA. So if you have been using Unity or some game engine, any other game engine, you know that we generally use colors in RGBA format, right? So it is the same format, right? Now there's also one thing, right? uh, what we have done till this code is we have built a triangle with three vertices, right? This, and this. But it has much more pixels in it than we thought. Like we never assigned all the pixels the same color, right? We are using it from here or from the code, right? So, like if we assign this pixel R, this pixel G, this pixel B, right? So what will happen? Will it assign everything R, everything B, or everything G? But it is not like that. What happens is like it will fill all the color, fill all the pixels with the blending color. So what is this blending color? Let's understand that. Rather, I will show it in the code itself. It will be much better. So in Vec 3, A color comes from the vertex shader. So we take input from our vertex shader, and like we out from the vertex shader, and we took input in our fragment shader of the output from the vertex shader, right? GPU automatically interpolate this value. Each pixel gets different blend color. So it gives the blend color, right? If vertices are red, green, and blue, GPU blend color smoothly inside triangle. You do not write blending code. So you don't write this blending code, right? But in further in further lecture, you will find it that you can code this to make your own type of blend, and that has some technical term that I will also explain to you. Now, what we are saying is outback 4 frag color, final color written into frame buffer. Now we give this color to frame buffer in the RGBA format. So it is RGBA format from RGB to RGBA. If you don't give the color, right? If you don't give the color, it will all will have the same color because fragment shader has like RG, this fragment color RGBA. So if you go to all pixel, it will be the constant value for the RGB values, right? So we will get the same color. Now the last thing after that, we will go to the code part and we'll make our first triangle, render our first triangle. So how we actually get three different color? Vertex data. First, we define vertex data, right? So this is our buffer. This is our buffer. This x, y, z values, x, y, and z values are stored in this color value, x, y, x1, y1, z1 value stored in this. Then our VAO comes and VAO says that it stores your position and you have stride of 1, 2, and 3. You have stride of 3. So we suppose we have 3 float equal to 1 unit for now. Suppose equal to 1 unit. So we will move 1 unit which will be containing this. We will skip this unit and we will move to this one. And similarly, here will be color which will be showing this, and we will also skip that and we will move to this from here to here, and this will be color again. So this box is empty. Leave it. 1 2 3 4 5 6. 1 2 3 4 5 6. So this is RGB, sorry, vector 3, and this is also vector 3, right? As we defined that our vector 3, from here this data will go to our vertex shader, and this data will go to our fragment shader. Okay, this is what we have learned for now. So each vertex has its own position and its own color. Flow of color data, VBO. From VBO it goes to vertex shader, right? It takes input E color. I think something is wrong with it. It gives output V color. Okay, GPU interpolates it. Fragment shader takes the color and assign it to frag color, and we take output from the fragment shader to our screen. So here's the data type. Important thing about data type that JLSL use: scalar type, type meaning float, 32-bit, int, integer, boolean, true or false. Vector type, very common, which we generally use, is this vec2, vec3, float, vec4. And then we have matrices too, matrices for transformation. Like if we have, like suppose we have a camera right in the space and we have to transform that to somewhere other place, then we will use the matrix to multiply it and we'll move it to further, like any location that we want. And we will also use it to make our first person camera. It is in the it is in our next video, I think. No, not next video, I think after 4 to 5 videos you will get to know this how it happens, right? So here is again that we have learned where things go. Fragment shader, what color each pixel. This is data type, and yeah, that's all. Okay, let's understand now how we going to write the code for this. First, we will include the headers for GLAD and GLFW, right? GLAD, GLFW. Then through this, I think GLAD used to make the windows and for the inputs, whatever it is. So through GLAD, we will create the window first, right? In this window, we have to render the triangle. So to render the triangle, we will initialize our vertex shader and fragment shader. We will write its code like the fragment shader code and the vertex shader code in the GLSL language. Then it will have some name in the strings like VC. After initializing the vertex shader, we will assign it to our vertex shader, and for fragment shader, we'll do the same. We will make VAO. We will what we say? We will make initialize VAO and VBO. In VAO, we will design how our data is in the buffer. Sorry, how our data is in the buffer. So like location of first vertex for the position, right? Then our data type, it's vec3 because our position is in vec3, right? Then our many two or three things. Then our stride, which will be 3 because after this xyz, we need to leave xyz for the color, like xyz for the color. Then again we will get another vertex position information after the 3 units, so stride will be 3. Then in the VBO, let me show the VBO what it does. VBO, like, it takes this data and like inputs there. It is like that only, like GL bind buffer VBO. GL in the GL buffer, we are saying that it is the size of vertices, so it will create a space for those size of vertices, and then it will assign this vertices in that. So this array is assigned into the buffer, and through this buffer we are drawing our triangle, right? So let's again do this same thing, right, from the starting. So let's include glf glfw. Okay, let's include glad glad glad.h. Now we have to include istream. I think file stream, we will work through the files after this. Like in the next stream, I will also tell you how you can write this code like the fragment shader and the vertex shader in different files and use it in the main file like this main.cpp. Okay, I will also tell you that. Now let's initialize the window. So we have to first make the window, initialize window. So glfw glfw window pointer. Yeah. So init window, it's a function that we are going to write. So uh, I have to check how we build the window, right? So so I think we have to first make the main int main, where our first call will be. Then we have to initialize, yeah, glfw. If glfw init, if it is not initialized, then we will say std cout fail to initialize glfw. Right now, what we have to do is, yeah, the pointer. Right. We will create the window pointer glfw glfw window pointer. Then we will assign glfw create window. We will ask this function to create a window of size 800 to 600 pixels. Is it pixel or width? In which unit? I'll leave it. Then we will name our window as OpenGL window, and we will assign this null pointer null pointer. For this video, leave it for now. What is this null pointer? Let's move to our rendering part. Now, if our window is empty, like it is null pointer, right? For understanding, I will say if it is null pointer, then std cout std cout failed to create glfw window, and then we will use this function to like terminate the glfw. Now, next thing is like we are saying that this window is our current context, right? So we are going to use this context to change anything in this window only. It will not affect the other windows. If we have suppose 2 or 3 windows opening and we have to choose one of it, then we will use its pointer to assign the context. So what we have to write is glw make context current, and we pass the window pointer, right? Now we will load the glad. It is just for initialization of glad, so that we can take input later and like use it for keyboard and mouse. So just write it what it is. Think maybe Maybe I'm forgetting something. Yeah, window hints, yeah. GLFW hint, init hint, major version, minor version, and yeah, the profile. Right. These three things we were forgetting. So now we have to load OpenGL functions. So we will use glad if glad, what is glad, yeah, glad loader, and we pass the glad load proc glfw get. Just remember this code. If you can't remember, just copy it, right? Now we will run our main loop. So what main loop does is it will run for forever till we don't close our window, so that, like, it's for running infinite times. If we don't run our while loop, it will just open and close. So we don't want that. We want that if we open our window, and it should not close till we don't press the close button. So we will use the while loop, and function, I think it's in loop close. Yeah, window should close. Window should close, and we will set window pointer in it. And if it is equal to false, then equal to false, and what we will do is, means we haven't pressed the cross button till yet. So what we will do is we'll do polling all events. So what this poll events do is it takes input, and like, it checks for inputs every time. If you have heard of CPU polling, you may resemble that too. It is kind of that, right? And what we're gonna do is GL clear color. Okay, we will give the background a color of this color. I don't know what it is. It's suggested by the copilot. I don't know. Now, if we have previous buffers, it also should clear that too. Then we will render NGL swap buffer. Its swap buffer is for buffer, like, when we run one frame, after one frame, if another frame has to run, we have to swap the buffer so that it could run. It is simple as that. Now, GLFW terminate. I think it's only thing return zero. Right. Now it's our first window. Let's run it. Uh, that's some problem. I think in header I have added it. Okay, that was the only problem. I think, yeah, build is successful. So here is our first window, and if we resize it, as you can see, when we are resizing it, its color is black, right? Its color is black. But as soon as I stop the uh, this thing, like holding the mouse, then it will shift its color. So the buffer is changing, and it is assigning color to it. And this is the color. I can change color in front of you for confirmation. Like, let's say this one to one. And now if I run this, so you can see it's purely green. Now, if I move it, as you can see, it is black color, like the buffer hasn't changed till yet. But as soon as I stop this polling, like it is now in the polling situation, right? I am using my mouse to poll it. But as soon as I remove my mouse click, it will assign the color. So it is here when I am using my mouse, and when as soon as I remove this function call, right, it reaches this function call and it assigns the color. So now it's time to render our triangle first. For rendering triangle, you know that we have learned about VAO, VBO, and how it works, vertex shader and fragment shader. So let's do that. Let's go here. So this one vertex signifies the left down corner of our screen. Like if we run our screen, and it will be the our left right corner, right? Write something here. Positions. Now I will assign the color 1.0 F 0.0 F, comma. Yeah, here's the full vertices, like it's for vertex position. This is the position, this is the position, and this is the position, as we already know. And this is for the color. It is for the color. Now we have to write our first shader program called vertex shader. Cursor. Y. Let me check if something's wrong in it. What's wrong? Expected a semicolon. Oh, my bad. So here, I think semicolon should be here itself. So for now, I'm using this format so that we can write code in this main.cpp file itself, but in future, I'll be making separate file for the vertex shader and the fragment shader, which is more organized way to do, and many of programmers do in that way only. So first, let's assign the what we say the version. So version core 3030, sorry 330, then oh sorry 334. After that, we will take input of our position. So vec3 a pose, then int main, the int main we have to assign this uh, yeah, we have to first give the layout location equal to 0. Then we are taking input from the layout location 0, and what we are saying is name it should be vec2, I think. Yeah, it should be vec2. Vec3 should be inside here after we give one more position vector coordinate to it. So gl underscore position equal to vec4 a pose comma 1.of colon should colon 2, and then since we have color 2, so we have also need color in it. So we will extract color from here. It's layout location 2, it's 0 and it's 1, right? So we already fetched the layout location 0, and now we will fetch the layout location 1. It will take input as vec3 and a color, and we have to assign this and take output our color equal to vec4 a color comma 1.of. So we have assigned this color to new variable name our color, and we will export this to our fragment shader. So we will write out vec4 our color. This is our fragment shader that we have wrote, and we will write now fragment shader const star fragment shader source equal to r. So uh, yeah, so first we define the version, then we need to take the input from this vertex shader to our fragment shader, right? So we will say in vec for our color, and also we will make a new variable frag color so that it gives output to our screen, right? We need to render the pixel. So void main, then in the main function frag color is equal to our color. So we have assigned the color to the frag color, right? So our fragment shader and vertex shader is ready. Now we need VAO and VBOs so that we can use this buffer, uh, add this to our buffer and render it with the help of the shaders. So let's make our VAO and VBO. So we have made two unsigned ints VAO and VBO. Now we have to initialize it, and let's first initialize it, and we will further go on and understand how whole thing is rendering. Then GL gen, yeah, GL gen buffer, then GN gen vertex array. So we have initialized the VBO and the VAO. Now, after initializing, we'll bind the buff VAO for now. Like we are using the VAO. This, if it is named like VAO2, then we will have to bind the VAO2. So if we have different VAOs, then we have to take care of what we have binded for now. So we have binded this, then we, oh sorry, we haven't binded. So now we will bind, right? GL bind array, what's that? Vertex array, okay. Vertex array VAO. We have bind our VAO. Now we will bind our VBO. So we will bind our this array buffer like it's internal, right? To our VBO, this unsigned integer that we made. We are binding this. Right? GL bind buffer, and we have binded both VAO and VBO. Now what we are saying that in this buffer that we have made, the VBO, in this we have to define the size of buffer that we want and what this buffer should contain and what type of draw like rendering it will do. So GL buffer data GL GL array GL underscore, yeah, GL underscore array buffer. I will write it by my own. So we will take of size of vertex vertices that uh, vertices array that we made, vertices comma vertices says comma. Now the last thing is, let me see. Yeah, the type that we want this drawing will happen, like the rendering will happen in which type. So it will be gl underscore draw underscore static static draw. Okay, static underscore draw. So we have set up our buffer. Now it's about attribute pointer gl trip see again gl vertex trip pointer b. Okay, then what we're gonna say is it's location 0 for now. Then so hmm, so the location is 0. We have 3, I think. What was that 3? See, then type is gl underscore float, then set gl false, and the stride will be of 6 size. Yeah, 6 size of the float, and there is no offset. Any arguments? Okay, okay. Why I'm using this get? Yeah, this is the correct thing. Where it is from? I don't know. Okay. So now we will enable the vertex attribute array like the location 0, right? And now for next location, what we will say is use this VBO. Inside this VBO, we have some colors, assign it. So let's do it for the color GL vertex attribute pointer, and the same thing, like you can also see it's the same thing, everything is same, but this time what we are saying is we have the offset of size 3 times size of float. Why? So in the previous explanation you remember that we have VAO and VBO. So suppose it has 3 size, 3 size, 3 size, 3 size. It contains position, it contains color. So for now, we only want to render the color, like this VAO only searches for color. So it has to go from this first color to its first color from for the next vertex, right? So we have 3 plus 3 unit. It's 6 unit difference. So it will go to 6 unit from here with the offset of 3 because it is, yeah, with the offset of 3 because the first 3 units was for the position. So we have to get the color, we have to get the offset of 3. Okay, and everything is same, and the location for this is the 1. So we are using the location 1 this time, and this location 1 is used here, right? This location 1 is used here. Now we will also enable this because we want to use it, so enable the location 1 too. Now we have to initialize the vertex shader and fragment shader. As we know, it is like simple string with R format. R format is used to like this slash. As you can see, if I hover over it, you can see /n/n. Like it automatically does the enter thing for us. So we don't have to write it by ourselves. If we use enter, it will end the line. Okay, so as you know, it's just a string. It's not fragment shader till now. So we have to initialize the fragment shader and put this source code here in the fragment shader and the vertex shader. Let's initialize the vertex shader first. Unsigned int vertex shader equal to gl create shader gl vertex shader, and same for the fragment shader. Okay, it's binding first, so let's just bind it. Okay, now same for the fragment shader. Should we compile? Yeah, we should compile the vertex shader first. So gl compile shader vertex shader. Then again unsigned in fragment shader gl create shader, and the type will be fragment shader type, right? Then again same thing as we did earlier here. For the vertex shader, we are going to initialize and put the value in the fragment shader that we created of from this our source, like the source we created for this program, the fragment shader source. We are going to put inside this. Now we have to compile this to gl compile shader fragment shader. So now we have set up our fragment shader too. Now what we need to do is call this both things together, right? The fragment shader and the vertex shader. So we will create a program which will call the both things together, which is shader program. Signed in shader program gl create program, and then gl attach shader program. We are attaching our vertex shader to our shader program. Same for vertex fragment shader. We will attach it to the shader program, and we will link the program to shader program. Like it's the same thing that we are doing. If we don't create this program, then what we have to do every time is run the vertex shader and fragment shader independently 2 times. Like, yep, it's bad. Now we have binded it. Now, as we created the program and compile it, after compilation, we don't need our source code, right? So we will delete our code. If you know that in a compiler, if we create some code, right? After that, we don't need our source code. Sorry. After we compile, we don't need our source code to run the program. So we will delete shaders that we made. Okay. Now in the window, right? Where is the window? Yeah. The main loop where polling will happen, we will render our triangle. Let's remove everything for now. If glfw get key, yeah, get key window pointer and glfw underscore key underscore escape, अगर इसे कोई प्रेस करता है तो देन glfw विंडो शुड क्लोज को ट्रू कर देना है, मतलब कि इसके बाद ये रन नहीं करेगा अगर हमने escape दबा दिया तो सो ये टर्मिनेट कर जाएगा. नाउ नाउ नेक्स्ट थिंग, टर्मिनेट करने के बाद हम फिर से वो विंडो जो हमारा बना हो उसको क्लियर कर देंगे एक बार, जिसको कुछ भी डिफ़ॉल्ट कलर दे सकते हो जिसमें RGBA वैल्यू होती है. एंड आफ्टर क्लियरिंग we will also clear the color buffer bit. uh, Let me search for it what it is, like we need to know. Yeah, so it's wipe the screen clean. So the black color that you were saying, like if I play for now, maybe, yeah, no window will appear. But as you remember, when we had window and we stretched the window was clear wherever we stretched. This is because of this GL clear color buffer bit. So it's clears those bits for new rendering. Right, that is what happening. Okay, so we have done this. Oh, yeah. So now we have to use the program that we made for the shader. GL use program, shader program. Then now we have to use our, yeah, bind the VAO. We need to use our VAO and GL draw arrays of GL triangle type, where you have to draw from the 0th vertex to the third, uh, with the three counts. So it will go from 0, 1, 2, like that. Now GL swap buffer, and we have to enable polling. Yeah, so we have enabled polling, and I think that's enough to render our first triangle. Okay, okay, let's see. We have to delete VAO, BBO, I think. Yeah, continue back. Let's run now. Let's see what's wrong. Okay, The hint window is wrong again. We have to use this window hint. It's not W hint. Okay, this. It should work now. Okay, let me share this to you. So this was the first problem, and the second problem, GL OpenGL call before context plus glad. Your code wrong order. GL gen buffer, GL vertex array, GL create shader. You must create window, make context, load glad, only then call OpenGL function. Okay. First we have to create context, then we can call this. Okay. So GL create context. It is, yeah. We are using the GL things before even adding it to the context. So we should put it here. Now let's try to run. Again problem. Okay. Let's see next fix. Vertex shader has multiple syntax error. Okay, okay. Just copy it. It has syntax error, vertex shader, location. Let's just paste it. Whatever we copied will be much better. It's the same thing, just cleaner. Nothing else. Now fragment shader type mismatch. Your code vec4 our color, out vec4 our color. But better practice pass vec3. Okay. So our color should be vec3, not vec4. Okay. Yes. The our color. Okay, our color is vec3. Right. It's true. Now next thing that we done wrong. Attribute size mismatch. Your vertex data, but your shader expect vec2. Use vec3 everywhere. Okay. I think it's okay now. It should work. Again, copy paste it. And let's see if it's working or not. Okay, glad load. We have to put this upward to this glad loader. Let's see now. Rebuild and apply. Okay. It's black in color. Let's see why it's black. Must have problem in fragment shader only. Okay. In fragment shader, we have to do this. Yeah, we are assigning it directly. Like it don't take value of uh, vec3. It takes for vec4. So yeah. Now it should render it properly. Yeah. As you can see, we have RGB colors on this corners in the vertex, and this thing are blended. this area is blended. This is what we have done for today. I think this is enough. And from next stream, we will be doing input and output. I think first we need to import more libraries for matrix multiplication, and for I think yeah, first we need for matrix multiplication and for textures. Yeah, we can do textures in the next stream. It will be much better. So goodbye. Let's meet in another stream.